Hi there, welcome to Guide Coachings. My name is Mozam Ali, and today we are going to discuss a very important interview related question, which is indexing. So in most of the time what happens is interviewer is checking your knowledge on indexing, how good you are with indexing. So we are going to learn about what indexing is. We are going to discuss about how we can create an index and what are the applications of it, why we use indexing. Okay, so stay tuned and we will be learning that. So let's start with the first thing first, that is what indexing does. So indexing makes your search operation faster into the database. So in actual we have millions and billions of data record sets into our database. So if we want to find out any particular record with where condition, at that time we need to have a faster execution and a faster optimization of our query, so that our expected record should be fetched easily. So that is the one reason, that is why we use indexing. The second thing is primary key. Whenever we create any table, indexing is applied onto that particular column where in primary key is declared. Then the third thing is index and where column relationship. We are going to see what is the relation between indexing and where column. Okay, so whenever we write a query like select star from where employee id is something xyz, so at that time we are writing that where condition. So we are going to see why where condition and index are related. Then we will be seeing then index created column is called as a index key. Okay, on whatever column you create a index, it will be that particular column will be called as a index key. Okay, now we have discussed about a basic idea of it. Now we will be discussing about the types of index. So there are two types mainly. The first one is clustered index and the second one is non-clustered index. In cluster index we will be discussing about the three important points. The first one is primary key. So whenever we create a table, we create a primary key inside that particular table, and we will be once we create a primary key onto a particular column inside a table, at that time what happens, system by default create an index on a primary table. That is the first parameter, or that is the first condition. The second thing is clustered index is applied mostly onto the numbers. So if we have employee id, department id, salary, commission, these are the types of numbers where we can apply clustered index very easily. Now we can have, as we know that we can have one primary table, sorry, one primary key per table. Okay, so that is the same principle applied over here, that whenever we create a primary key, the index is created by default for that particular column, and that principle is followed throughout the table. So we can have one clustered index per table. Now we'll discuss about non-clustered index. So non-clustered index again have three parameters. The first parameter is it is applied on characters. Okay, so if we have employee name, department name, and uh, address, or the their gender, these types of things are uh, comes under characters. Okay, so we will be creating a non-clustered index on the values where the characters are present. Then there are different indexes. Okay, so here in clustered index what happens is the indexing resides inside the particular location where the table is created, but this is a referential index which can be stored at a different location. It is just a logical relationship between that particular non-clustered index. It can be different from the table. The third thing is uh, as we know that we can have a foreign key, multiple foreign key in same table. The same concept applied into non-clustered index, that it can have many non-clustered index inside a table. Okay, so you can have a different clustered index for your name, you can have a different clustered index for your department name, and different clustered non-clustered index for your gender. That is how we can do it. Okay, but clustered index will be once per a table. Okay, this is the basic difference between clustered and non-clustered. Now whenever we perform any operation onto any, any database or any table, three things happen when we do a search or select. So the first thing is it will scan a simple without any indexing. The scanning happens onto that particular table without any indexing. That is the simplest and the most basic way. The second is it will have a unique index. Now unique index scan is identifying a unique record inside any in that particular table using primary key that we have discussed. Okay, then we have the third thing is sometime what happens is we have department id or the employee id. Now see, understand the difference. Employee id will be unique per record. Okay, if I'm working into an organization, so my employee id will be unique. This will not be given to any other, or my entry would not be repeated inside the table. But in department table, uh, we can have multiple employees, but all those employees will be having one department id inside their table, inside their record. So if suppose I am working into sales domain, so sales domain or sales department, it will have id 101. And my colleague is also working, so his department id will also be 101. And if 10,000 millions of employees are working into that particular department, they will have the same department id. That is the condition. Okay, so in that situation we will be having a range. Okay, that is one situation. And the other situation is we have a salary brackets into the organizations. Okay, so if you are m level, you will be having salary from 20 lps to 50 lps. If you are associate level, you will be having a salary of 3 lpa to 6 lpa. So that is the salary brackets. So whenever we want to search any particular record inside the database, we will be writing a query like select star from where salary range between, or where salary between you know uh, 1 lakh to 3 lakhs, or 3 lakhs to 6 lakhs. That is the range. So at that time we create a range index and it has a range scan. Okay, that is how it works. Now we will be understanding a binary tree. Okay, so by default index is a binary tree. Okay, as you can see right onto the screen, we will be having a preceding value and a next value, which with the actual value. So let's consider a situation where we have 2,50,000 records inside our database. Okay, and we want to find out any particular record. Okay, so how it is divided? It is divided on the basis of the binary architecture. What is binary tree or b tree is, it will be having a next value here and a preceding value over here. And it will, whenever we want to create an index, how we can create it? We will be writing create index name, the way we write it for create table name, create procedure name, create view name. The same principle is applied over here. See, SQL is very simple, very basic. If you pay attention to one topic, you will automatically learn the other topic. Now here, how you will create index? You will write create index name, then you will be writing on table name, and then inside the bracket you will be writing the column name, on which column you want to create. So if you want to create on employee id, you can write employee id over there. If you want to create an index on department id, you can write department id over there. Now b tree will be the best choice when we have a huge data with unique records. So as we discussed two situations, the first one is employee id. Each employee inside the employee table will have a unique id. So in that situation we will be using a binary tree, and that is the best solution. Okay, unique index. Then if we are dealing with a salary bracket, or we are dealing with a department id, at that time we will be having multiple of employees having department, same department id. So at that time that is not a ideal situation. Or whenever we have a salary range where associate employees having a salary of 3 lakhs to 6 lakhs, at that time b tree is not a ideal solution. Now we will be discussing about the clustered index. So what is clustered index? We have seen an example. So we have discussed about it, what are the parameters and what are the things which are important inside it. So as you can see on onto the screen, we have one table where employee id is there and employee name is there, or fruit id is there and fruit name is there. Now if I want to apply a clustered index, it will be applied by default on my id. Now if I talk about non-clustered index, as we discussed, it will be applied onto the name side. Okay, now here if you see, it's again a binary tree, it's a binary search operation. So what is the benefit of it? We will be discussing it now. See here, I have total in this is my structure of my database, where I have 2,50,000 records stored inside it. Now the first level of node is called as a root node, and we have intermediate nodes. Okay, this is intermediate level, and the last node which we call as a leaf node. These asterisk you see are nothing but the null values, so that it does not have it ends over here. Okay, so it's the next value is ends here, this ends here, this ends here. Slash n is my null values, it does not hold any addresses. So this holds an address of preceding, that is the uh, preceding values address, and here it will holds the address of next. So whenever it finds, if I want to find out a salary which is equals to 500, so let's suppose I have this is as my root node. So it will go here, then it will check it is greater than 1 lakh or less than 1 lakh. If it is less than 1 lakh, it will, what it will do, it will go to my 50,000 bracket, it will not go to my 12 lakhs. So half of the records or half of the filtration is done in just one one search, that is the binary search. Then once that is done, it will be checking whether this 500 is greater than or less than 50,000. So it is less than 50,000, so again it will go to my next operation, and in only in three steps, easy steps, it will find out the exact result. Okay, ultimately it has 2,50,000 records, but see the simplicity of finding out the expected result. Similar way it can be vice versa. If I have a salary of 2,50,000, or if I want to find out a salary who if I want to find out an employee whose salary is 2,50,000 or more than that, then in that situation again it will take the three steps. So okay, so the smallest one or the greatest one, it will reduce the level of finding to the result. That is the best part of binary tree, that is why we should use it. Okay, now when why we are using the index? So as I mentioned, it creates or it make your process faster. Okay, so if you don't use a index, and if you just create your table and then just execute it, so without indexing, what happens? If we are going to see this in practical as well. So what I will do, I will just quickly take you to the practical window, and I'll just show you the actual number of rows has 1 million. Okay, it had 1 million rows, and I wanted to find out one record. Okay, that is my I just want to where employee salary is equals to, or the employee id is equals to 9,000, and if I hover over it, I can see that actual number of rows red is 1 lakh, and it found that it has only one. So it is a very difficult one if you do not use a index. Okay, if you use index, you can see here it just you know if you use index, so here if you can see, total number of rows read is 1 and number of all execution is 1. So see, this is the difference between the with index and without index. If you are applying index, it will directly gonna search that particular id. If you are not applying the index, it will gonna take a lot of time. What we will do, we'll see it practically and we'll check it. Okay, so what I will do, I will drop this table first, and I will create it one more time. Earlier I have created for millions of records, but it slowed my process, so I will just be showing you by creating very 100 or 200 or 1000 records. So what I have written over here is my simple logic. Okay, using while loop. So I have declared counter over here where integer is equals to 1. Now I am checking the while condition that counter is, unless and until counter, I'll just add 1000 records. Okay, so unless and until counter is less than equals to 1000, begin. Okay, till that time you need to go inside it and then declare ename. Okay, I'm declaring ename, and I am applying a rtrim over here, and I am adding the counter over here, and I am declaring one more variable which email id, and I'm adding that email id to it and with guide coachings. Okay, then I am inserting this value, whatever value I have created over here, I insert into employees table which I have created over here. Okay, once that is done, values, I'm inserting that, I'm setting that value. Okay, I'm setting the counter is equals to +1. So whenever any counter, any record, so this is my first record, and first record will be having counter 1, and that is apple 1, and apple 1 at the guide coaching. This is how it will be going to happen. And then here, okay, and I can I just don't want this to be printed, so I will simply remove it, and I'll do like this. Okay, so here it will increase the counter and it will end. So when it will end, when the it will check the condition, and when the condition is satisfied, it will end the execution. Okay, so now I think I have created the table. I will execute it. I'll go to message. So as you can see, all my records started inserting into the database. Okay, see this, these are the records getting inserted to my table. Thousands of record I'm adding without any repeating any record in it. Okay, so this will be continuing till some time. We'll come back to it and we'll see the difference, how the search operation will be happening with index and without index. Okay, so meanwhile what I will do, I will, yeah, so here I have written the select employee, select star from employees. So we'll be searching for that, we will be checking that, and we will be checking the employee id which has the 900 as id. Okay, we'll be checking for that. Again my execution is happening, guys, so it will take some time. Again we'll come back to it and we'll be seeing that. Okay, so now we will be we have seen with index and without index. We will be going to see very very soon a practical example of it. Then we will talk about non-clustered index, with non-clustered index, and without non-clustered index. So as you can see, I have taken a screenshot of my query where I am selecting select star from employee, where employee name is 9000. Okay, apple e name. So now here if I check for the name, I can I can see the difference. Okay, so what I will do, I'll show it better. Okay, I'll just stop it so that we can see the results. Okay, I have just stopped my execution. Now I'll execute this and we'll see how many records we have. Okay, we have a lot of records over here. Okay, 186 records maybe we have. Okay, so now what I will do, I will change it to 185. Okay, this is without index. So if I execute now, this execution plan, how it came, if when you click on this actual include actual execution plan or control M at the time, this execution plan will option will be enabled for you. Okay, so you need to click on it first, and then you will be selecting this, and then you will be executing. Once you execute, see the result. Okay, and I'll go to execution plan, and when I hover over it, I can see clustered index, and you can see the records over here. Now why this happened? Because of employee id will have a default clustered index applied over it. Now if I want to find out for name, okay, then what I will do, okay, so these are the points which I supposed to tell you, that I have already told you that we can go to execution plan and we will be validating the execution, we will be activating it, then non-clustered index sort values alphabetical order. Okay, so now we will be discussing about a non no this, that is non-clustered index. So non-clustered index, what it does is it creates a key value pair. It creates a key value pair whenever you apply it. So before applying it, we will be seeing it for 180th record, and I will just execute this. Okay, now this is executed. Now I go here, and as I can see here, so see this, if you can observe this. Okay, I cannot know over it, but if you can read actual number of rows read, okay, 186, it find out all the records, that is it search for all the records, that is 186 time it searched, and then one record it found, that is the actual number of rows for all execution. Okay, so this increase the repetition, this increase the load over the system without non-clustered index. So now what we will do, we will create a non-clustered index over it. So, and this is this is inefficient way from performance standpoint. As I mentioned, it increases the load onto the system, so this is inefficient. We need to have some optimized way so that we can find out the name, the gender, or the department name if we want to find out. So how we can do it? We can do it using non-clustered index. So we have seen the example of this is my clustered index example, but here if you see, it is it does not have any indexing. So how we can do it? I can create an non-clustered index. So we will create non-clustered index, and then we will write the index name on, and then we'll give the the table name, and then we will give the name of the column on which we want to have it. Okay, so if we want to create a normal index, we will write create index name. Okay, index name, and then we will write on, and then table name. Okay, table name, then we will be having the column name. Okay, this is my syntax, but if I this is for clustered index. Clustered index is default one, which will be automatically created for any primary key holding column. But here if I want to create a non-clustered index, I need to write a non-clustered keyword explicitly. Once I have executed command executed successfully, and now I will be executing the same query. If I execute the same query, see, if I execute the same query over here, let's see what happens. So if I execute it, we'll go to execution plan, and I'll just hover over it, and you can uh, here we have executed for it, and a non-clustered index has been created. Okay, because it is statics already exist. Yes, it we have already created this. So this is the execution plan for it, and we can see that actual execution. Okay, we can see the actual number of all execution is 1. Okay, number of red row red is 186. So that is how we can optimize the execution of the uh, by creating a non-clustered index. Why okay, now we will be seeing about the with index and without index difference. Okay, so whenever we have n number great millions and billions of records at that time, the execution process takes time. So if we consider on the performance standpoint, we can see estimated subtree cost is 0.0065. It took 0.0065. Okay, and here if you see for the 100 record, it took over here, that is estimated subtree cost is 0.0096. Okay, so 0090 you can see for 100 records, and for 9000 record it took 65 milliseconds of 0.0065. Okay, so that is the performance improvement which happens, and you can see it over here. Okay, as you can see 0.0086 is the time for the record to be found inside the database. That is the importance, and that is the advantage of using the index. Okay, now there are certain points to remember while you are working with index. The first point is index created on columns used in where clause. Okay, so this was the point which I wanted to make, that whenever we have a where we will be applying a index, so that when we use a where column, so where, okay, so where, here we are giving a command that this specific name I want to find out inside the table, so that it ideally when we give a where condition, we are using the column name. So on this column ideally we should create an index, so that it make the easy. So like if you have a book, and we have indexing at first, so we can refer those, we can read out the subject lines of that particular index, and we can find out the page numbers of it, so that it is easy for us to access that particular chapter or that particular topic inside the book. Then we just see the number and we just go to that particular page number, and we can check that particular value. So that is the reason whenever we are creating a where condition, we need to have a column name, and on that particular column we will be creating a index. Now columns with primary key and unique key constraints have default index. We have already discussed that uh, columns which have primary key or unique key constraint have default index. Now the third thing is index improve the performance for each search, but it also increase the delete and update. So whenever we are deleting something or when we are updating something, at that time it takes some time to identify that particular element, so it will again search for that particular element and then do it. Now if I think that okay, if it makes the process faster, what I will do, I will create index on every column. No, that will again increase the pressure, or it will hamper the performance of your SQL server, where it will search for each and every column, and it will make your query, or it will take a longer time to execute your query. So the best way is whatever the important columns you have in your table, you can apply uh, index to those columns only. Now index increase data redundancy, and if we want to see all the indexes created onto the table, we can write out this command, that is select star from user index, user underscore indexes. So this will give all the indexes which are present inside the table. Okay, and if we want to find out that okay, on this particular table how many types of indexes are created, so we will be writing select star from indexes, user underscore indexes, where table name is equals to employee, where table name is xyz. Okay, so this is how we can do it. Now I want to put some light on the uh, simple types. So whenever we execute any query, we have, we can have a composite index, we can create a composite index. Now what is composite index? So composite index works as a same as composite primary key or a composite key. you know as I mentioned earlier, that everything is repeating itself. So if you understand one concept, you are going to understand the other concept as well. If you have learned about the composite key or the composite primary key, you may be remembering that whenever we create a composite key, at that time we create a key by joining two columns, the uniqueness of two columns. So if we join a department id and employee id and we create a composite key out of it, so it will not take the same department with same employee id. Okay, it can take a different employee id with same department id. Like earlier 5 records you have added with the same department id, but every time the department, the employee id has to be changed. Or the same department, the same employee id can be into different department, same employee id can be into different can be used with different department ids. Okay, that combination is also fine. Okay, that is the use case of composite key. Now we are talking about composite index. So composite index, what happens is we take two columns names and we put inside the composite key, and we create a composite key index. And then whenever these combination, like employee id and department id are used together in where clause, so it will make the search faster and easier for the system, or the for the SQL server, or the uh, uh, SQL server to process the data easily and quickly. Okay, now we'll see create how we create index. We write create index id. Okay, then create unique index. We can also create a unique index as well. If we want to create a unique index, what we will do, we will write create unique index, then the rest of the thing will be same. Okay, composite index key, this is what we discussed just now, where we have employee id and department id. Okay, so I will be writing create index and composite. We can give any name on employees, and here we have given only one column. Here we can give multiple columns as well. We can have department id, or and we can have gender id. So likewise we can create a combination of multiple different keys to make it easy for searching. Now function based indexing, we can have, we have created, let's suppose a scenario where we have created a non-clustered index which we create on names and characters. Okay, so if we say and we know that in SQL everything is case sensitive, sample with capital S and sample with small s are not the same. Okay, so to ignore that, so if we have applied a indexing on capital letter, and we are passing an input with the smaller letter or the small case, at that time that index won't work. Okay, so to make or to adjust that situation, what we will do, we will create a function, or we will apply a function, so that whatever input is given by the user, we can cast it to the expected one. So if suppose I have all the entries in my database by capital letters only, I ask user to enter only in capital letters, but when these entries came into my system, okay, they are in capital letters, but as a T SQL or SQL developer, I am trying to I'm putting the smaller case. So at that time, what I will do, I will use a function over here. I can use a function over here, and I can get the result. So if I whatever input is given, so if it is given as a uppercase, it will take as a uppercase, but if it is given as a lowercase, it will this function will convert it to uppercase, and then it will give to the system, and system will use that particular indexing which I have created for my capital letter names or values, and this time it will work. Okay, so this is nothing but the same function or the same statement, that is create index name, index name, and then here we will have a table name, and then on and then we will have the column name. Okay, on here we will have the on as a value. Now see the variation. Okay, I can have one column over here, or I can have more than one column over here. That is the composite. Okay, composite indexing. Then I can use a functions inside it. So I can use upper. Okay, if any column name is have some upper or lower case, I can use that. I can use lower case as well. I can use lower. Okay, if I want to have a lower case, I will be writing that. If I want to have a non-clustered index, by default this all are clustered index. So if I want to have a non-clustered index, I will be writing non hyphen clustered clustered index. Okay, and it will be the name of this particular index, and then it will have on, and then table, and then this. Okay, and if I want to have a unique one that is remaining, so I will just copy paste it, and I can have a unique index. Unique. Okay, this is how I will write unique index. So these are the types of index which you can create, and which you can improvise the performance. Remember guys, you cannot create more than it is not advisable just to create multiple combinations of indexing, because ultimately what it does is it starts to check each and every condition, and which increase the load onto the system. Now bitmap index, the last point of the session is bitmap indexing. So bitmap indexing is very important, and it is used for uh, generally for the values which have true false 0 1, male female yes no type of values. So bitmap is used for that particular thing. I hope I have covered most of the things into today's session. If you have any questions, any queries, or any doubts regarding the topic which we have covered today, you can write me a comment, and we will be discussing onto it. That's all for today. Thank you so much. Have a nice day. Thank you.